Hello everyone, welcome back to the channel. In this video, we are going to look at another problem from LeetCode, and the name of the problem is flood fill. So according to the problem statement, we'll be given an image which will be represented by an m cross n matrix. Okay, where each cell contains an integer which represents the pixel value of the image, and we'll be also given three integers sr, sc and color. So sr, sc are the coordinates of the starting cell in the matrix, and along with that we'll be given a color integer. So basically we need to perform a flood fill operation on the given matrix. What we need to do is that we need to begin from the starting pixel, and then we need to consider all those pixels which are connected four directionally to the starting pixel, and they must be of the same color as the starting pixel. The same way, any pixels that are four directionally connected to those pixels also with the same color only, and so on. We need to replace the color of all these cells with the new color which will be given to us. We need to return the modified image matrix after performing the flood fill, and the like this we'll be given an integer matrix and the coordinates of the starting cell, and we need to expand the new color in this matrix starting from this beginning cell. Now let us see the approach to solve this problem. So let us consider this example. This is the image matrix that we are currently having, and let's say the starting coordinates given to us is 2 comma 1, which means that uh, we need to begin expanding the new color starting from this particular cell 2 comma 1. Okay, and as you can see, the color of this starting cell is 1 as it is having integer 1. Okay, now we need to gradually check all the cells that are four directionally connected to this starting cell, and if they are having the same color as the starting cell, then we need to change their colors to the new color. New color that is given to us is, let's say, 4. We need to change them to integer 4. Now let's say if we are at a particular cell, then we need to check four directionally all its neighboring cells. So let's say that we are currently at this cell with coordinates x comma y. So first we are going to check all its neighboring cells that are four directionally connected to this. It means that uh, the coordinates of the cell immediately above this cell will be x comma y plus 1. Coordinates of the cell immediately below this cell will be x comma y minus 1. Coordinates of the cell which is immediate left of the cell is x minus 1 comma y, and coordinates of the cell which is immediately to the right of this cell will be x plus 1 comma y. Right, so for each particular cell we will check all its neighboring cells, and if they are having the same color as the color of the starting cell, then we are going to change all their values to the new color given to us. So now we need some optimal algorithm so that we can gradually expand this new color starting from the start cell which will be given to us. So we have two options to solve this problem. We can either use DFS algorithm or we can use BFS algorithm. Uh, so basically DFS is a good to go algorithm to solve this problem. We will start from the starting cell and we will consider all the cells that are 4 directionally connected to the starting cell. And if the color is same as the start cell, we will change its color, and then we are going to continue searching for all the neighbors of that particular cell first, like we do in DFS. So we can either use recursion and expand the new color in the entire matrix wherever we need to do, or we can also use BFS. So in this particular problem, I have used BFS. So in BFS, what we do is we take a queue, first in first out queue, and in this queue we one by one pass all the cells that we need to consider. Then we will check all the neighbors of those cells one by one, and we will keep adding new cells in our queue. So as we all know, queue is based on first in first out. Firstly, we will push the coordinates of the start cell in our queue. So the coordinates are 2 comma 1, and then we will one by one process all the cells present in a queue at a time. So as currently only one cell is present, 2 comma 1, so we will pop this cell out. We will color this cell with the new color given to us. So the value of this cell will become 4, and then we are going to one by one check all its neighbors, and if their initial color value is same as the start color value, then we are going to add them. We will change their color also equal to the new color, and we will add them to our queue. So after that, for this cell, as you can see that the only neighboring cell which has color equal to the start color is this particular cell, which is having value 1. So we will change the color of this cell to 4, and we will push the coordinates of this particular cell in our queue, and all the other neighbors that are 4 directionally connected to this particular cell are not eligible. And as you can see, this cell is not 4 directionally connected to the initial cell which we are considering. So we will not push the coordinates of this cell, but we will push the coordinates of this cell. So the coordinates are 1 comma. Then in the next turn, we will process this particular cell in the same way. So in the next turn, when we will pop this, so again we will check for the neighbors of this cell now. This is the current cell, and if we talk about its neighbors, then these two cells are having values equal to the start cell color. So we will change their colors. So firstly we will change the value of this cell, and then we have to add the coordinates also of this cell in our queue. And the next cell is this cell. We will change its value to 4, and we will add the coordinates of this cell also, which is 0 comma 1. We are done with this particular cell, so we will delete it. Now in the same way, in the next turn, we have two cell coordinates in our queue. So one by one we will pop them out. So when we will pop this cell coordinate 1 comma 0, so it is this cell. Now usually while performing DFS or BFS algorithms, we usually maintain some data structure to keep track of visited nodes. It can be either a dictionary or an array or even a matrix. But in this problem, we don't need any extra data structure to keep track of the visited cells, because in this case we are already changing the values of the cells. So it will help us to not revisit the previous cells which we have already visited. Like in this particular cell 1 comma 0, the 4, if we consider the neighbors of this cell, then uh, it has three neighbors, this, this and this, and the values of all these cells are not equal to the start color value, which was 1. Hence we will not change the value of any of its neighbors, and we will move to the next coordinates present in our queue, which was 0 comma 1. Now we are talking about this particular cell. So uh, if we consider the neighbors of this cell, then only this particular cell is having value equal to the start cell color. So we will change its value to 4, which is the new color, and then we will add the coordinates of this particular cell, because it might be possible that the coordinates of this cell whose value we have changed, it might be possible that the neighbors of this particular cell should also be transformed into this new color. So that's why we will push the coordinates of this cell in our queue. And like this, our BFS algorithm will work, and I hope it makes sense to you. Now let us quickly move to the coding section. This is the C++ code. Here I have initialized a queue where we will store pairs of x comma y coordinates of each cell, and in the beginning I am pushing the coordinates of the start cell, which will be given to us. Here I have taken a variable start color, which will keep the color of the starting cell, and then I am changing the color of the starting cell to the new color which is given to us. And in order to check for the neighbors of each particular cell, I have taken this array, and in a while you will get to know what's the use of this. Now while our queue is not empty, we will perform our BFS. So one by one, here I am popping the coordinates from the front of the queue, and as you can see, we are iterating through the directions array which we have taken. So the value of element can either be -1 or 1. Firstly, if we subtract 1 from the x coordinates which we popped out from our queue, then it means that we are considering the left neighbor of the current cell. And if we add 1 to the x coordinate, it means that we are considering the right neighbor of the current cell. So here we are checking if the new coordinates of the neighboring cell, if they are valid, and if color of that cell is equal to the start color and it is not already same as the new color which we want to paint it, then we are going to change its value to the new color integer, and then as we discussed, we will push the coordinates of this neighbor cell in our queue. In the same way, if we subtract 1 from the y coordinates, it means that we are checking the cell which is immediately below the current cell. And if we add 1 to the y coordinates, it means that we are checking this cell which is above the current cell, right? And if this cell coordinates are also valid, we will change the value of this cell to the new color, and we will add the coordinates to our queue like we did before. At the end, we will get our modified image matrix, and we will return that matrix. So this is the simple solution. You can go through this code, and I hope it was clear. This was it for this video. If you are new to this channel, please consider subscribing and also share it with your friends. Thank you and have a nice day.